Okay? So a catalyst is something that is used up in one reaction but is produced in another. So in this reaction, the nitrous oxide is used up in step 1, but it is produced in step 2. Therefore, it is able to go back and destroy more ozone. So that's my catalyst. The intermediate is produced in one reaction and used up in another. So this is my intermediate. Okay. They want to know the ratio of the rate constants for the catalyzed and uncatalyzed reaction. So what I'm going to do is I'm just going to erase that so I have a little bit more room to work. So the formula for K is A e to the negative EA over RT. Now for they want the ratio of the catalyzed to the uncatalyzed. So for the uncatalyzed, for the catalyzed reaction, EA is 11.9 kilojoules per mole. In joules, it's 11,900 joules. Okay? And the reason why I converted it to joules is because my R value is also in joules, 8.31 joules mole Kelvin. My temperature is not changing. We're at 25 Celsius or 298 Kelvin. Okay. So the uncatalyzed is at 14,000 joules, and the other two variables stay the same. So if I plug in the uncatalyzed on top, that's the catalyzed, and then I'm going to set up a ratio of the uncatalyzed that's what I've got. So I'm going to kind of simplify it a little bit. So I'm going to K over catalyzed, K over uncatalyzed. And I'm just going to calculate that. Obviously the A's cancel out, so we don't have to worry about that. And so then I'm going to take the exponential of that product. And it comes out to be 0.00818. And then you do the same thing on the bottom, and it comes out to be 0.0035. Yep, 351. And so if you just divide those two numbers together, the ratio of the catalyzed to the uncatalyzed is going to be approximately 2.3. Okay. Number 79. As to how is a graph It says, how could a reaction go from a rate order of 1 to a rate order of 0? So the graph kind of goes up like this. So something like that. So in the beginning, your rate law is to the first order. And then when you get into this plateau region, your rate law then switches over to the 0 order. So in other words, it's saying if I increase the concentration, my rate increases. But at a certain point, when I increase the concentration, the rate stays the same. Okay? I think one of the best explanation for this is to think of it as in terms of biological system. So in your body, you have enzymes. For example, let's say the enzyme to break down sugar. Okay? So you've got these enzymes, these proteins, and they have a shape such that it will perfectly match with your substrate. In this case, sugar. So most of the time your enzymes are just sitting around doing nothing. They're waiting for the substrate. So you have all these enzymes just sitting around there. If I add sugar, if I increase the amount of sugar, I'm going to increase the rate of the reaction. Because as I add more of these sugars, they can work. But once all the enzymes are filled up, once all the enzymes are occupied, adding more sugar is not going to increase my rate because they can't go through the reaction. All the enzymes are filled. So basically, no matter how much more sugar I add, the rate's not going to change. That's when it switches over to the 0 order. All right? Thank you very much. Have a wonderful day.